So now if we continue with radicals containing variables and do some operations with them, we kind of basically follow the same rules we did when they were numerical values under the radical signs. So adding and subtracting, you can only add them or subtract them if they have the exact same radical part, when meaning the radical sign has to be the same, index has to be the same, and then the value underneath, or the expression underneath the signs have to be the same. So you can only combine like radicals. And when you're multiplying and dividing, you have to have the same radical sign, so the index has to be the same, and you basically can multiply the numbers or expressions out front of the radical signs by each other, and the numbers that are underneath the radical signs by each other, provided that the radical sign is the same. And then you should always check your final answers to see if any further simplifying can be done. So let's try a few examples. All right, so each of these, the instructions are missing here, but you should simplify, basically, is what you're asked to do here. Simplify each of the following expressions and write your answer in simplified form. So when you look at these radicals here, they all have a root x, so they would be considered like radicals, so you can add these. So 4 root x's plus another 2 root x's is 6 root x's, minus 7 root x is going to be minus 1 root x, or just a negative root x. And this one here, in B, 20x, they're both square roots, but 20 and 5, 20x and 5x are not like, but 20 can break down as 4 times 5x under the radical sign, because 4 is a perfect square factor of 20. And then you'd have the next step, the square root of 4 would come out as a 2, and you'd be left with just the square root of 5x. And you still have plus 3, whoops, didn't mean to write that extra 3 in there. 3 root 5x, so now you do have like radicals, and this would be 4 root 5x plus 3 root 5x. So again, you just basically add the numbers in front of the radical sign, so that would be 7 root 5x's. And you don't need to break that down any further, because 5x cannot be broken down. There's no perfect square factors of 5 or x. In C, you can break down the x cubed as x squared times x. And the next one, minus 4 root 2x, can't do a whole lot with that. So then the next one, next line, you'd have the square root of x squared can come outside as an x, and you'd be just left with x inside. And minus 4 root 2x, can't do anything with that. So this is just 8x root x minus 4 root 2x. So there's nothing really that we can do past that, because you're subtracting two terms, but they're not like radicals, so you'd have to leave it in that form. D, you can take out the square root of 4 as a 2, and the square root of x squared, x to the 4 can come out as x squared. So basically, you wouldn't have anything left in under the radical sign. The next one, though, you wouldn't be able to take out the square root of 8, but you can break it down as to 4 times 2. And then the x to the 4 is a perfect square. So in the next step, we have 2 times 2 x squared, which is 4x squared. And this one, the square root of 4 comes out as a 2, and the square root of x to the 4 comes out as x squared. Remember, you take the half of the power, basically. And then all you'll be left with inside is this 2 right here. So 4x squared, actually there's nothing more you can do with that, because 4x squared is simplified as much as it can be, and 2x squared root 2 has a radical part with it, so you cannot add these. They're not like terms, because even though they both have an x squared, this root 2 is not in both terms, so they're not like radicals. The next one, for x, again, you have to break down the 18 as 9 times 2, and the x to the 5 as x to the 4 times x. And in the second expression, you can break down 32 as 16 times 2, and x to the 5 as x to the 4 times x. So we're going to simplify each radical first. And then that would be negative 4x times the square root of 9 comes out as a 3, and the square root of x to the 4 comes out as x squared, and we are left with just the 2 and the x underneath the radical sign. In the second expression, we have the square root of 16 comes out as a 4, and the square root of x to the 4 comes out as x squared, and we are left with a root 2x, again under the radical sign. So this becomes, if we multiply the terms out front together, this becomes negative 12, x times x squared is x cubed, root 2x, plus, next one would be 32, x cubed, root 2x. Just move that up to get a little tiny bit more space. So now, if we look at it, they both have exactly the same radical part, and the terms out front are both x cubes, so they can be combined as negative 12x cubed plus 32x cubed, which would be 20x cubed, root 2x. And the last one, you're multiplying now, last one on this page anyway, you're multiplying, so you multiply the terms out front. Actually, you could, if you want to simplify this first one here, is 5 times x can come outside, and you're left with root 6 inside. And then the other term, there's not much you can do with that. So then if you multiply the terms out front, you're going to get negative 10x squared, and you're going to get 6 times 2x is 12x. So there's a little bit more simplifying you can do, because 12 now under the radical sign can break down as 4 times 3, and you still have your x there. And then negative 10x squared, the square root of 4 comes out as a 2, and you're left with 3x. And then you have negative 20x squared, root 3x, when you multiply the terms out front. And the 3x cannot break down any further, so you're finished. Right, if you multiply in G here, again, you can simplify first before you multiply, because the y squared could come out as a y. Out front of the square root of x would be left inside. And then you got times your 3 square root xy. So when you put those together, you've got the 2y and 3 get multiplied to give you 6y. And under the root sign, you have an x times xy, which is going to be x squared y. And so now, because there's an x squared there, that x can come out. Square root of x squared comes out as x, and you're left with root y. And most times people will put the variables in alphabetical order, so they'd write that as 6xy root y. Okay, h, you're going to be basically doing what we did before, distributive property again. So the 2 root x will get multiplied by the 5, and then minus the 2 root x times the 3 root x. And then you have to multiply the 3. 3 would get multiplied by the 5, which is plus 15. And the 3 would get multiplied by the negative 3 root x, which is going to give you negative 9 root x. So this is going to be 10 root x minus the 2 and the 3 will get multiplied to give you 6 root x squared, because you multiply the numbers out front by each other and the numbers under the radical signs by each other. The 15 can't do anything with that, and 9 minus 9 root x. So the 10 root x and the 9 minus 9 root x are like terms, so 10 minus 9 is 1 root x. And the square root of x squared can be replaced with x, and so there's nothing remaining under the root sign now. And all you have then is root x minus 6x plus 15. And there's nothing more that you can do with that. Okay, so again, we're using the distributive property. So root x times 2 root x is going to be root x times root 2x, and not 2 root x, root 2x, sorry, plus root x times root 8x. And then that's going to give you, the x's can multiply by each other, so you're going to get 2x squared under the root sign. And this one you're going to get 8x squared under the root sign. So this comes out as x, you're left with root 2. And this one you've got 4 times 2. And the x squared can come out, I'll just put that out in the last step. So this will be x root 2 plus the square root of 4 comes out as a 2, the square root of x squared comes out as an x, and you're left with just the 2 underneath the root sign. So now you have x root 2 plus 2x root 2, so that would be basically like terms again. So you got 1x root 2 and 2x root 2's for a total of 3x root 2's. The next one would be negative 3 root x gets multiplied by the 2 root 2. And then the negative 3 root x gets multiplied by the negative 3x, so that's going to become a positive 3 root x times 3x. And again, you multiply the numbers out front, so that'll be negative 6. And you multiply the radicals by each other, so that's going to be 2x. Plus the numbers out front, well, there's no radical with the second one, so that would be 9x root x. And you can't really put those together because root 2x and root x are not like radicals. All right, so now we're into division. So again, same rules apply, but we're just dealing with variables now. So I would probably break these down first as x squared times x over negative 3, and the square root of x squared would just be x. And that would be 15x, because the square root of x squared would come out as an x. You'd just be left with a root x over negative 3x. And then you can cancel common factors, because 3 goes into 15 5 times, and these x's can cancel. So you'd just be left with 5 root x over negative 1, which is the same as negative 5 root x. The next one, you can't simplify individual radicals, so and within the radicals, yeah, the 7, there's no perfect square factors of 7 or x, there's no perfect square factors of 10 or y, but there is a radical in the denominator, so you have to get rid of that by multiplying top and bottom by root 10y to rationalize the denominator and get rid of the radical square root in the bottom. So when you multiply the radicals in the top, they're both square roots, so you can all go under the one's root sign as 70 xy, the square root of that. And the bottom one, when you're multiplying the square root of 10y by itself, you're just going to get 10y. And there's nothing more you can do with that, because 70 does not have any perfect square factors, and neither does x or y. So you've got the radical that is there is broken down as much as it can be, and there are no radicals in the denominator, so that's considered simplified. So the next one there, we did do ones like this before where we separated the numerator over the same denominator, but I just tried that one quickly, doing it that way, and it was a little bit long. So we're just going to take this one as it is and leave it as 6 root 5 minus 2, and 24 has a perfect square factor of 4, so 4 times 6 is 24, and x squared times x would be your perfect square factor x squared of x cubed, all over 2 root x. So we're just going to simplify that second radical there on the top first. So this would be 6 root 5 minus, this becomes 2 times 2, the square root of 4 comes out, the square root of x squared comes out as x, and you're left with 6x inside, all over 2 root x. So then you've got 6 root 5 minus 4x root 6x over 2 root x. And the only other thing that needs to be done now is you can't have a radical in the denominator. So you'd have 6 root 5 minus 4x root 6x. You can't combine those because they're not like radicals. But you can multiply top and bottom by root x to get rid of that square root in the denominator. And that's going to give you, you're going to basically multiply the root x by both of these. So the 6 root 5 will get multiplied by the root x, and the 4x root 6x will get multiplied by the root x, all over 2 root x times root x is going to be just 2 times x. And then that's going to give you 6 root 5x minus, this is going to be 4x, and 6x squared will be underneath the root sign, all over 2x. And there's one more thing you can do, and that's to bring out that x in the second radical on the top. So you'd have 6 root 5x minus 4x times x root 6 all over 2x. Still long doing it this way. Oh, got no space left. So we can squeeze that in here. So 6 root 5 x minus 4x squared root 6 all over 2x. That's a square there. All right, so there's some questions there in your textbook that you can try related to this material.